Evening. We're going to look at Chapter 4, Lesson 1, 2 ways to estimate fractions. We're going to start with the lesson on using compatible numbers. As we know, compatible numbers are numbers that are close to the original or to the actual numbers and are easy to do mentally or easy to do in your head. The whole reason we estimate numbers is so we can do them in our head. So if I wanted to estimate 1/4 times 13, I would have to find a multiple of 4 that's close to 13 because 13 and 4 are not compatible. So if I think what is close to 13 that 4 will go into evenly, I'll know by knowing my basic facts that 1/4 times 12 is compatible because 4 goes into 12 3 times. So how do I do this mentally? Do you guys remember? 12 divided by 4 is 3, and 3 times 1 is 3. So an estimated answer is 3. That would help me to look at my actual answer and to know if I am getting close to the actual right answer. So if we look at 2/5 of 11, I'm going to look at my 11 and 5. They are not compatible. 5 will not divide 11 evenly. But 5 will divide 10 evenly. So 2/5 of 10 is 10 divided by 5 is 2, and 2 times 2 is 4. If you remember our model, it would look like this. This number represents 10, and I need to split it into 5 equal pieces. So this shows me that 10 divided by those 5 equal pieces is 2. So each piece is 2. And I need 2/5. 2 out of those 5 pieces. So right here, this is my 2/5 part. So 2 plus 2 is 4. Okay, let's look at 1/5 of 16. I can see that 5 and 6 are not compatible. What is close to 16 that 5 will go into evenly? That's 15. So remember, 15 divided by 5 is 3, and 3 times 1 is 3. My model would look like this. I'm splitting up 15 into 5 equal sections. This means I'm doing 15 divided by 5. So each section would be 3. If I put those together, 3, 3, 3, 3, and 3 equals 15. I only need one of those, so 3 is my answer. And finally, 5/6 of 13. 6 and 13 are not compatible. What is close to 13 that 6 will go into evenly? 12. So I can think about this as 12 divided by 6 is 2, and 2 times 5 is 10. My model would look like this. I have this bar representing 12. I want to split it into 6 equal pieces. That shows me that this is 12 divided by 6, which is 2. So each section of this bar, when split into 6 equal sections, is 2. I need 5 of those. So if I look at these 5 here, I put those together. 5 times 2 here gives me my 10. So that's how I got 10. So that's one way to estimate with fractions. Another way is to round your numbers to either 0, 1/2, or 1. Okay, and we're going to call these benchmarks. A benchmark is a whole number or fraction that's easy to use when you estimate. So the benchmarks of 0, 1/2, and 1 are useful when estimating fractions. So we're going to complete this table together, but first we're going to look at a model, of course, of what fractions are. So let's let this model down here be our ruler. And at this end of the ruler we have 0, and at this end we have 1. So right between 0 and 1 is 1/2. Okay, so these are our benchmark fractions. We're either going to round things down to 1, round fractions down to 1, round them up or down to 1/2, or round them up to 1. All right, if we were to take this ruler and split it into more pieces, let's split this half into halves and this half into halves. So now if we count the equal sections, we have 4 equal sections. So this must be 1/4. This one is half is 2/4, which is the same as 1/2. This is 3/4, and then we get to 1. Okay, I'm going to split up those 4 equal pieces so the whole ruler is even going to be cut into smaller pieces. So I'm going to take each of those and cut those pieces in half. Now if I counted the equal amount of sections, you can see I'd have 1, 2, 3, 4, 5, 6, 7, 8. So from here to here, this must be 1/8. We already have 1/4, that's 2/8. Here's 3/8. 4/8 is equal to 1/2. Here's 5/8. 3/4 is equal to 6/8. Here's 7/8, and my 1 whole would be my 8/8. Okay, so I'm going to split that up even further. So I'm going to take each of these little sections and cut them even smaller. So if we counted how many, these should be equal, how many equal sections we have, we should have 16 equal size sections, and I know these aren't really equal. Fix it here. As equal as I can get them. So if I counted each section, there's 16, so this is 1/16. 1/8 is the same as 2/16, so I'm done. 3/16. 1/4 is the same as 4/16. 5/16. 3/8 is the same as 6/16. 7/16. 1/2 is the same as 8/16. 9/16. 5/8 is the same as 10/16. 11/16. 3/4 is 12/16. So we have 13/16. 7/8 is 14/16, and the last one's 15/16. So what I want you to do with this ruler is to look at some fractions up in your table so we can kind of see where they relate to 0, 1/2, or 1. So let's look at our description. The numerator's close to 0. The denominator's not close to 0. So our 1 and our 8 describes that. So 1/8 is about close to 0. 3/16, 3 is far away from 16. And if we look over here, we can see that our 3/16 and our 1/8 are closer to 0 than they are to 1/2. So those two numbers we can round to 0. If the numerator is about half the denominator, then we're going to round those to 1/2. So let's see where 3/8 is. 3/8 is right here, pretty close to 1/2. We know that 4/8 is exactly 1/2, so 3/8 is pretty close to 1/2. If we find 9/16, there it is right there. And we can see how close it is to 1/2. And 8/16 is half of 16, so 9/16 is a little more than 1/2. And then the last benchmark that we round numbers to 1, the numerator and the denominator are close to each other. So 7/8 on our ruler is right here, pretty close to 1 whole. And 15/16 is close to 1 whole. So these are the type of fractions that you round to 1. Now go ahead and try these below, and we'll see how you do when you come in. Have a great night.